everyone, we're going to identify and graph the polar equation r equals 3 minus 3 sine of theta. Alright, this is a cardioid, and I will show you the form for this in just a minute. Right now we're going to look at the graph and test for symmetry for condition 1, condition 2, and condition 3, so we can see what it's symmetric to help us with the graph. So the first one is condition 1. So if we have r equals 3 minus 3 sine of theta, we're going to replace our theta by negative theta. So we have r equals 3 minus 3 sine of negative theta. If we get an equivalent equation, then it means it's symmetric. However, you know that sine is an odd function. That means we're going to bring this negative out front here, and that's going to end up being 3 plus, because you have two negatives here, 3 sine of theta. Since these are not equivalent, it's not symmetric to the polar axis, i.e. the x-axis. So let's go to condition 2. For condition 2, we're going to replace our angle with pi minus theta to see if it's symmetric to the line theta equals pi divided by 2. So let's write this as r equals 3 minus 3 sine, and instead of theta, it's going to be pi minus theta. So it has this form here, some indifference. So let's write this out as equals 3 minus 3, and this is going to be sine of pi cosine of theta minus cosine of pi sine of theta. Alright, now this equals 3 minus 3. This is sine of pi is 0, so you get 0, that goes away. Minus a negative 1, that's negative 1, and then sine of theta. So this is going to end up being a plus 1, so you're going to get 3 minus 3 sine of theta. Now, it is equivalent to my original, so this test passes, and it means our graph is going to be symmetric to the y-axis, or the line theta equals pi divided by 2. Alright, now for the last test, this one's the easiest. You're going to replace r with negative r to see if you get the same equation. And if it is, it's going to be symmetric to the pole or the origin. And if this is not squared, then it's going to be no, because you're going to have r equals 3, negative r equals 3 minus 3 sine of theta. So this fails. This is only going to work, this condition 3, if you have r squared. Alright, this is why this is a cardioid. It's because we have this form here, where RA equals 3. And then we have the minus thing going on. So here's like a sample of the graph. It looks like a heart. So let's go ahead and graph this. Since it is symmetric to the line or the y-axis, we're going to look at values of theta from negative pi divided by 2 to pi divided by 2. So I'll just put that like that. I'm trying to save room here. So we're going to we start with theta, and we're going from negative pi divided by 2 to pi divided by 2. So let me see if I made enough room this time. Just write down your angles as you go around the unit circle. Pi divided by 6. Oh, I did better this time with the spacing. Alright. Now our equation is 3 minus 3 sine of theta. So we substitute in our theta and write our value. So we'll get 6 here. This is going to be 3 plus 3 square root of 3 divided by 2, which is approximately 5.6. For this one, we're going to get 9 halves, which equals 4.5. And at 0, we're going to go to 3. At pi divided by 4, we get 3 halves, which equals 1 and 1/2. At pi divided by 3, we're going to get 3 minus 3 square root of 3 divided by 2, which is approximately 0.4. And at pi divided by 2, we're at 0. So let's plot these points and then apply our symmetry to our axis, our angle equal pi divided by 2. So we're starting at negative pi divided by 2, which is here. And this is your origin here, so go out 6. So this is 1, 2, 3, 4, 5, 6 right there. All right, and then at negative pi over 3, which is this one, we're going out almost 6. So let's go on this line, 1, 2, 3, 4, 5, 6. So go back a little bit in there. And at negative pi over 6, this is 4.5. So we're going to go out 1, 2, 3, 4.5. It's about there. Where are we? At 0, we go out to 3. So look at this line, 1, 2, 3. At pi over 6, we're here. And we're going out 1.5, which is about there. And then at pi divided by 3, we're at 0. We're really close to 0 here. And then at pi over 2, we're back to 0. So let's see what I can do with this. So we're drawing, this is our starting point. You're drawing around here, going through here, and it's going like this. So there that is. Now again, we said it's symmetric to theta equals pi divided by 2. So basically what you want to do, and you can kind of match this up, just don't overwork so much. You're going to kind of match it up to our graphs here, 1.5. So it's going to come back up around here. And then you're going to match these up, pi over 3. Pick some key points here. This one's going to be, what was that? Oh, that was 4.5. 1, 2, 3, 4.5. So kind of just go through these points here, and there it is. Should look like a heart. Thank you. Have a nice day. Bye-bye.